Hey everyone, this is Martin, and this is part 6 of the OpenGL C++ FPS Game Engine walkthrough devlog that I'm doing. So it's been a few weeks, it's been a good few weeks since I've done anything in terms of on the YouTube channel. So I thought I'd give a very quick update today. It might not be very long, but this is the scene where it was up to a few weeks ago. There's been changes since then. I don't think these 3 balls were in there last time. I think these were added in afterwards since the last video, part 5, but I think the block physics objects were in there last time. I can't remember if this sort of springboard here, this multiplier is in there, or this platform. Yeah, again, it's been a while since I've checked the channel and the videos, but yeah, this is what we've kind of got in terms of the 3D world. It's still very laggy, as you can see. This is something I'm going to handle once I finish the course, once I've gone through all the videos. Probably it just needs to have these bullets pooled because it's instantiating them each frame, each time it's been clicked, and that's a bullet physics object and a mesh each time. And this is a very, very laptop, so if it can run fast on here, it can run fast on anything. So yeah, so this is where it was up to a few weeks back. What I'll do is I'm just going to stop this and go to Visual Studio, and I'm going to check out the newest one because there has been a good chunk of updates, like I said, since then. And I'll walk through kind of what I remember and just pick things out, as I always do. No particular structure to these videos, but just glancing through the code and trying to understand it myself. But you can see jump platform has been implemented there. This was, when was this? 1st of March, and we're on the 24th now. Sprites have been done, so that was the other big thing. Basic UI and text rendering as well, which is pretty darn chunky video from the course that I'm following along on to make this FPS engine. But let's just check this out, and we'll move to the latest one. And then what we will do is, it might take a moment to compile actually, because it is a little bit slow. Again, it's a very old machine, but hopefully it won't take too long. But yeah, text component rendering was a big chunky set of videos. It really was. A lot of it kind of went over my head, or well, some of it went over my head. The glyph system, the reading things in, it sort of made sense, but I'm going to have to go into it deeper to really understand what's going on. It uses the FreeType library, which allows you to load in and read basically parsed TrueType fonts from what I can see, pulling out all the data. So within the project, it's using Arial, the Arial font. Let's just go back in here. This looks like it's all been updated now. So text component rendering, boom. Let's go back in. Yeah, that's all updated, and it's not a very exciting scene to look at. It is just the sprite, so the 2D sprites, and then UI after that. So 2D sprites being rendered before UI, and I'll show you the sort of the draw call. I think it's in graphics API.cpp over here. I'll let this build for a second. Yeah, it's compiling, but I can kind of just dig around as we're talking about this. In fact, no, it's in renderq.cpp. So this was, I don't know if you call it a light bulb moment, but it started to kind of click a little bit better when I was seeing this sort of like as different passes. So you've got the main draw call here, and commands are passed into this renderq.cpp. So we're submitting a command, but only at the very end of the frame do we call draw. So the new one here was pushing a new 2D render command and a new UI render command. Now, these are all broken up into the passes. I think that's pretty much what you call these in kind of Unity land, and probably in other engines, or graphics in general. But you've got the 3D pass here, which renders all the 3D objects, and then you've got 2D here. So that's because the set depth test enabled to false means that it renders on top of all 3D objects in the world, even though it's can be at the 0,0 world position, and that's because it's just ignoring the depth test. The fact that it's drawn after just means that it's going to be drawn on top of anything 3D. So we draw all 2D sprite based, objects there as well. Then finally, the one that I've done recently, following along again on the course, is UI. And then that all gets rendered here. Now the cool thing with this, and again, forgive me, this is quite scattered. I'm just pulling things out here as I'm going along and talking about them as I see them. But batching system. So this was very interesting as well, because it kind of made it a little bit more concrete in my mind of kind of how batching works. Now I had a fairly good idea of how it worked only, but I'm seeing it implemented here. Helps it solidify a little bit more. There you go, it's just popped up on screen. So let me see if I can get my mouse up. Probably not there, I'll have to close it down. But as you can see, we're rendering a sprite position 500, 500 with some rotation, and then we're rendering some text in screen space at pixel offset 300 by 300. So bottom left is 0, 0. So that is cool. It's very, very simple there. We've skipped all the 3D stuff here. That's going to be re-implemented back in the next couple of videos or the next couple of chapters that I'm going to go through. And this will all be combined together. But let me just go back there. We'll stop that. Again, just randomly picking stuff out here, but we've got a batch within the command.batches. So we're able to just render each batch, and then for anyone who might not know what a batch is, and you know, anyone out there, please correct me if I'm wrong on this, if I am, but a batch is basically like a single draw command sent to the GPU that allows you to render one or more objects. So in my head, a batch is just a single draw command, and in the case of text that you just saw on the screen there, it allows you to write all of those individual glyphs, all of those individual characters in the text in a single draw call, because each of those is a single rectangle. You know, the S and the O and the M and the E, they're all like individual quads, and it uses a texture atlas to pick out the area from that texture atlas to draw within that quad. So you know, it knows the offset to draw the S, the offset to draw the O. And that is drawn in a single command. So all of the vertex data for each of those letters, S, O, M, E, T, E, X, T, is contained within a single buffer, a single vertex buffer on the GPU. And then draw call is sent, and then with each letter, the offset is set to the different position, different sizes, so it knows which quad to draw where. So that's a kind of very rough understanding in my mind, anyway, of kind of how that works. You can see here, like in this case, we've got draw indexed range. So we're not just drawing everything within the vertex buffer. This is the range. So, for example, index, you know. Let's say it's the M in some text, then it will know the offset is X number, whatever, 12 bytes, and then the number, the count that we want to render is 4 or whatever it may be for like the 4 vertices, and then it moves on to the next one. So that's roughly how this works. So let me go into the definition here. Yeah, so this is GL draw elements is the OpenGL command, and this is slightly different to what we were doing before, where we're just, again, this is a ranged draw. So we've got draw elements up here, which was just, hey, triangles, the number that you want to draw, and the starting index. Now here is the difference, or the big difference is we're starting at a different index. So there's an offset into the vertex buffer of where we start drawing for that particular batch. So this is, again, I always say this in every video, but I do need to like dig around more and kind of understand, but it'll begin to sink in as I start to add more videos, and eventually I get around to updating this to build it into some kind of FPS game, once the course is finished. So updates the vertices in the GPU vertex buffer, so update dynamic. So this is a big one as well. This is in mesh.cpp, is GL draw dynamic. I can't remember whether this was different before. I think it was. It was static before, and now it's dynamic. I think so. Maybe it was, maybe it wasn't. I'm not sure. It's turned into quite a chunky course, and there's quite a lot of code now. But anyway, what this allows you to do is, as it says there, updates the vertices in the GPU's vertex buffer, and this is called each frame. So bind the buffer, the vertex buffer that we want to use, the data that we want to add. And again, dynamic says that this is going to be changing often and it's not static. And I think that allows OpenGL to optimize how this particular buffer will work, because you're saying, hey, I'm going to update this very often. And so each frame, it's sending all of the data of the, let's say the text, all of the vertices that make up that some text, each frame, and then just calling, hey, draw, and then it's able to draw all of those, again, all of those quads that make up that string in one go. Let's just go back a little bit, and I know, sorry, I keep saying this, but I'm just going to dive around and see what's what. The view call hierarchy, by the way, I've not used this in Visual Studio before, but I found this pretty handy, was being able to get a tree of where things are called from to this function. So calls to update dynamic. Why is that not showing me anything there? Calls from. That's odd. Something calls to update that. Did this not implemented yet? Okay, that's interesting. It might have been this one. View call hierarchy. Let's take a look. There you go, flush. Yeah, so this was handy anyway. So you can sort of go down the tree here. It's not ultra new. Got it in other IDEs, but I just found it useful here in Visual Studio. I hadn't seen this before. So flush, I think, gets called every frame. This will probably search in a moment to show update, and it allows me to kind of go back, because this is the canvas component that I'm just looking at right now. And the canvas component is kind of similar to the one that we find in Unity as well, which handles UI. So I might have made a note at the top here somewhere. No, it wasn't. Maybe it wasn't that one. Or was it on canvas component.h? The root level component for all UI elements. Yeah, so this is the canvas component. Acts as a central manager. It traverses a scene graph, finds all UI elements, and calls their render methods recursively. So housing all of the UI elements, as it says there, under a single game object, then calling, render on each of those, whether it's a sprite or eventually or a button or text component. This is all handled through the canvas component. So you stick the canvas component on a game object, then under that have separate game objects. In fact, I'll dot around here. Where is game.cpp? Concrete example. Game.cpp is the client code, the actual game code, not the engine. But here, kind of, might as well highlight it as I'm saying it. But we'll create in a game object called text. There we go. Sorry, let me go backwards. Sorry, a game object called canvas, and add in a canvas component. Boom. Then making a game object called text, and we're adding it as a child of canvas. So if that wasn't added to there, it wouldn't render. But that's the kind of the pattern of the hierarchy, where you'd have all UI related components rendered if they live under the canvas component. So yeah, that was interesting, and again, similar to how it works in Unity, is we have a canvas component that lives on game objects, and that handles rendering of all UI objects underneath it. So let me just have a dig around as we're talking. So mesh update dynamic, yeah, we're passing the vertices and the indices. So being more efficient there, we're drawing based on indexes and not doubling up on the vertices. Graphics, compose the rendering command for UI. I do want to find the batch stuff again. Where was the batches? Yeah, so command, we're building up the render command. If we go back down here as well, so calls to flush comes from update. Excuse me. And this is called on the canvas component again. it's that system of, I think we'd call it ECS, entity component system, where we're putting components on objects. The call execution is from engine update loop called onto it. The game objects within the scene, their update loops called, and then game objects, each of their components. So it goes down the entire hierarchy. I don't know why this isn't finding this. Let's just go hierarchy in this one. But I believe this gets called every frame. Draw rect as well, just while we're waiting for that. Actually gets called from? What does that get called from here? I can't remember which order that gets called in, but let's just take a look. Okay, calls to flush should be an update from canvas component, I think. It's taking its sweet time. This is an old potato, though. It really is. There you go, update canvas component. So yeah, begin rendering. This is kind of what I was talking about before. So loop through all the child objects and render any that contain a UI element component. Yeah, so recursively all the way through, render any of them that are a component, and then let me go into render. In fact, go to definition. Element render, yes. Loop through all the child components and render any that contain a UI element. So this is going through children of children, and then calling render again. Let's go to that definition. We're just going in circles here, aren't we? Yeah. So begin rendering. And then after that, I think it was called flush. So after we've called render, then that's when we're building up the render command and then sending that submit. We're submitting that command to the render queue. So again, this is something kind of like engine architecture, which kind of clicked for me a little bit. Always something that, yeah, it clicked. But basically, you build up the commands to draw, and then finally, building up the commands is where you'd say, hey, submit this command. And then finally at the end you'd call draw for each of these, and again that was the sort of the passes that I was telling you about before. If I just find out where draw is called as well. That does come right at the end of the main engine loop, if I remember. Calls to draw. Let's just see. Again, this is very slow. It is a super potato though, honestly. You can usually click on like find all references, but it seems to find references to anything that's called draw, which it can be contained within the third party, the bullet physics library or whatever. And it's so weird. I don't know why it's doing that. I'll have to, maybe I'm just using it wrong. I'll have to figure it out. Calls to draw, engine.run. Yeah, so this is the main engine loop here. Stepping back, so there you go, there's the big old while loop. Engine.run is called from client code main.cpp, and I think render yada, where's draw and current scene, and render queue.draw. There you go. So that happens last after update on all of the objects is called, which happens somewhere. Application update, I think that's where it happens. Yeah, so physics manager is done first, and then updates all of the game objects, its components, clears, and then all of the render jazz happens. Clearing the back buffer, setting up the matrices, and then finally calling, hey, draw all of the objects that were submitted to be drawn. Let me find these batches thing, because this was something that I did want to highlight, just have a little dig into, as I mentioned before. There you go. So batches is here. If I go to we're building up the render command here, and meshes, command up batches equals m batches. So this is the canvas component. Okay. So the canvas component is handling all of the batches together. Now this is or the canvas component, that sort of top level component which handles all the drawing of the UI, is also the handler for all of the batches, it looks like, because we've got m batches here, you see, which is, if I go to the declaration, yeah, canvas component.h handles it, and and I've actually put like a specific like note on there and on where this was referenced within the lecture as well on Udemy, because it was handy. So this handles all the batches. So I think what was happening was it would, if something is batchable, as in you're rendering a bunch of text and it's all using the same material and the same texture, then we can batch that into a single draw call and all of the text can be rendered at once. Whereas if it was a sprite with a different shader, and like we saw with that brick sprite there, or there's some different material values, I think, I could be wrong on that, then it has to be a separate batch, and that's where the batch number gets updated, or a separate batch gets added. So if I just go to mbatches, update batches, add another batch of text to a different one. So there we go. Yeah. Canvas component update batches. I'm going to click on call hierarchy whilst we look at this for a second. In fact, update calls to batches. Get rid of that. Update batches. So it's very late again tonight, everybody. I'm a little bit slow here. Add another batch to texture is different, as it will need to be drawn in a separate draw call. Yes, so the first one is created if the batches is empty, or if the texture that's used at the last batch is different to the one that's been passed in, then we create another batch. And again, like that's like a separate draw call, because as you saw the back at sort of the start of the video, if I go to render.cpp and UI, yeah, there you go. So for each of the batches, then call draw index range again, and that goes into that GL draw elements call that we saw before. So the more that you can batch, the better. So the reason why I'm harping on about this, or just I wanted to dig a little bit more into this, is because there's, with this kind of knowledge, or with this writing the engine code here, I should be able to optimize if needed, or go. I can go in deep into figuring out, okay, how can I do less draw calls, because the more batches or the more draw calls that's into the GPU, the heavier, the more time it's going to take, the more effort it requires and time, just because that call from the CPU to the GPU is heavy. So there's, in Unity land, as few of you probably know, you always want to kind of reduce the amount of draw calls as much as possible, because that's communication between CPU and GPU can be a real bottleneck. Now, it's not always the case. That's not always the culprit of maybe a laggy game. Of course not. Could be a heavy shader. Could be that's something that's just strictly on the CPU. It could be just the number of objects, even if that you're drawing in the world, even if they are batched, or even if you are using instancing. But as a sort of general rule, keeping down the number of draw calls and number of batches is good. So my ramble here, the point is that I can do like a check to see, okay, how many draw calls am I doing each frame? How many are being sent to the GPU? Specifically, within this render queue here, how often are we calling draw index, range, or if I go to that definition there, it's in mesh.cpp, and I can have some kind of like debug, okay, this frame, 20 batches were called, or draw elements was called 20 times or 30 times or whatever, and I can figure out, okay, how can I batch this? How can I make it better? So for example, you can see here, like one of the things, this is just off the top of my head, what I'm looking at right now is if we are swapping textures, we're going from an Arial texture font or whatever to some kind of, I don't know, Tron font or whatever it may be, then that's a new batch. Okay. But then let's say it goes back to Arial again, and because the last one was the Tron font, now it's going to push back another batch. Okay, so is there a way that I can organize the draw calls so that the we group the textures that are the same together, and therefore we don't have to make another push, another addition to the batches, to the draw calls. Instead, we can just do this, where we increase the number of calls in that batch, or the index count within that batch, so that it's a single draw call with more stuff. So, I'm rambling, blah blah blah, but you get the point. Hopefully, I can optimize this. Is what I mean, because I'm learning and I'm actually writing the engine through the course. I don't think there was anything else really that I kind of wanted to dig too much into. I think the big thing was the test component here. This is kind of stuff that I've gone over before, where we load properties from within a JSON file as well. I don't think I've done this yet. Test component load as in I don't think this code actually executes. I think this is I wonder where this gets called from. The reason I say that is because I added a text component sort of manually through the game.cpp file, as you saw at the beginning of the video or halfway through the video. I mean up here, that's where I'm adding text component. It's not coming from the scene.sc file here. I don't think it is. Text. No, it's not. So I don't think this thing gets called here, unless it's... Yeah, I mean, it's still load property still probably gets called somewhere, but I'm not sure. But the point is, I guess what I'm thinking is that you don't have to load, or I don't have to load a text component like this in the scene. Sorry, in the client code, the game.cpp file. If I want to display some text, I can just add this within the scene file here. I want to have a life bar, life counter, some kind of on-screen text, like lives count, whatever it may be, or game over, from within this scene file, as opposed to directly within the client code here, if that makes sense to do it that way. This is all what I'm kind of figuring out as well, and probably what I'll understand more when I come to actually building a game based on this engine, based on this course that I'm going through, where I have to figure out, okay, where do I load things dynamically via the client code? Where do I, like, for example, creating a bullet at runtime and shooting it? Yeah, that makes sense. You wouldn't want that in the scene file. UI overlay. So, for example, game over, game finished. Would that be a separate scene file? Would it be within the scene file? In Unity land, again, I'm tying this all to Unity a lot because that's where most of my experience lives. It would be a UI prefab within the scene that can get it's either part of the scene already, or potentially what you'd have is maybe a kind of a base scene, a base level scene, which then loads in the which loads in each of the levels dynamically, and this is basically a UI prefab that you load in each time you load a level. So would that be in a separate scene file? Would it be dynamic? I've got to figure it out, is what I'm trying to say. But yeah, to be figured out. I think that's pretty much all I wanted to go over. Oh, there was just a couple other things here. There was a font manager as well, which loads. Oh yeah, that's what I said at the beginning of the video. Sorry, I've completely skipped over this. Was the font manager loading stuff? So it was pretty chunky, and I kind of understood some of it. But we're using third party, the FreeType. There you go. So the FreeType library, which I think is just an open source way of loading FreeType fonts, or just fonts in general, maybe. But the font manager is the muscle behind this. And when you call get font, I think this is where all of the magic happens in terms of loading. If I go to definition, load the font from the font file and cache caches in M fonts. Yeah, so we get a path to the file. In this case, it was in the assets folder, this arial.ttf here, and this is defined all the way back in, or this is defined here of where the font file lives. Font manager loads that. I think init is called way from the engine edit as well. In fact, I'm curious. I think all of these kind of init calls are called from the engine.cpp. Init calls to init, I think, yeah, and font manager init should come from engine.cpp, I think. Engine.cpp, run font manager. There you go, font manager init. I found it. Boom. And that gets called away at the beginning from, I think, main.cpp, or potentially from one in the engine. Sorry. Anyway, what I was looking at was this get font part here. Yeah, so we'll load the asset file. So try to find the font if it already exists. If not, we'll load the asset file. Shouldn't do that. We'll load the asset file from the path provided. This is where we get into the loading of the font face and the complicated stuff that I didn't quite understand, to be honest, and I'm going to have to like read through it separately at some point, or maybe not if it just works. It depends whether I'm going to really need to get deep into this. But this FT is all of the FreeType stuff. So new font memory face, a reference to the library that we're loading it into. Reinterpret cast, I need to understand this a little bit more, like sort of dynamic casting versus static casting within C++. But we're getting the data that we want to load. Setting pixel sizes, okay. Determine the atlas size for the final texture. So yeah, I guess this is a good point of something that maybe not everybody knows, but from my understanding is because we're using rasterization and the details that are contained of fonts within a TrueType font file are basically mathematical descriptions of what the letters should look like. So, you know, like a T, it would say, oh, you know, the top of the position is, the top of the T is sort of 0.1 from the top of the, well, from the top of the glyph. The cross or the bottom part is 0.9, so we're normalizing, you know, the left side is this distance, the right side is that distance. So it's all described mathematically, is what I'm trying to say. And since we're not able to draw it that way, we have to render all of the glyphs, all of the characters, into a texture. And that is what we call, well, a texture atlas, because each of those individual characters, each of the individual letters, are all contained within that texture. And then when we do a draw call, we know where to offset into that texture to make the correct letter appear. So yeah, that's kind of what this is in terms of making the texture. So we determine the size of the atlas. Again, some of this I wasn't clear of. You know, we're a bit shifting right 6 here. Square root of 128. I'm not sure why we're doing that. Create the RGBA buffer to fill with zeros. Okay, so yeah, we're actually filling up the buffer with all of the details that we're actually creating the buffer size. Then we're rasterizing all the glyphs here, and then 128 characters. So we're using the standard ASCII set here, which is 128 characters and uses basically 7 bits of data. It's not the extended one, which uses all 8 bits of a byte, and therefore is 255 or 256 characters long. It's just the basic one, or the standard ASCII set. And then if there was an error, loading the character. And then again, this is where it got a little bit, I'm not sure exactly. The font description is like the size, the width. So this is where we pulled out the data of the glyph. So you've got here glyph description. I think maybe if I go to this, go to definition, glyph description, is it up here? Yeah, glyph description, there you go. So lower left corner position in the texture atlas, upper right. So this is again, like it says right there, where it lives within the atlas as well. So we can pinpoint, or we can pick out the correct area of the atlas to render the correct character, because that texture atlas is going to contain all the characters. But going back, so glyph bitmap. I am just like repeating what the heck I'm looking at on screen here. Copy the glyph into the bitmap. So is this the part where it's actually writing the data into the bitmap and then copying that into the texture? I'm not sure. Yeah, again, it was a bit, I'm not sure what's going on. Fill in the glyph description, which I get, in terms of like the size and where it lives within the texture, and then create the texture from the atlas. Okay. Create texture from atlas, so font M texture equals M texture, yeah, okay. So that's where, this is sort of me like noting down what the guy was saying as we were talking. So create texture from an atlas. See, I thought an atlas was a texture, so I don't know if that was misspoken a little bit or whether I'm just being stupid. Cache the font, yeah, as we did, and then at the end we do a cleanup. So this was all a little bit roughly following along, but not 100% to be honest. But that was chunky, I guess, is the part that I wanted to elaborate on a little bit as well, was this whole font manager and loading fonts, and fonts are pretty complicated. So luckily we do have like people who are very smart out there, and much smarter than me, who have put together libraries like this FreeType here, which is available open source as far as I'm aware on GitHub. But you're able to load like true type fonts, and then you can extract all the data and do what you need. So interesting stuff anyway. But we've got text rendering on screen now. The next chapter in the course I think is going to do with buttons, so that should be interesting. I wasn't sure how that's going to work. It's AABB testing as far as I'm aware, in terms of where the mouse is on screen. That's going to be pretty interesting. We might talk a little bit about layers as well within that chapter. So layers, if you click on the screen, if you are clicking on a UI object like a button, how do you make it click the button as opposed to shooting the gun, which is in the 3D world? And that layer is like, hey, layer 0 is the UI. Did we click on anything? No. Okay, then we pass the event down to the next layer, which would be the 3D world. And then did we click on, did we click to shoot, or did we click on some object in the 3D world? So that layers might come into it in the next couple of videos in the course. What am I talking about when I'm saying course? If you're seeing this video for the first time, or you're not sure, basically it's a Udemy course that I'm following along with, and it's like I've just described at the beginning, an FPS C++ OpenGL course. My goal at the end of all of this, and I'm close to the final chapters, is to start to put together some kind of game with levels. So I'm thinking something very basic. I've mentioned it before, something along the lines of maybe Doom, or maybe something like or maybe some kind of puzzle FPS like Portal, something like that, but not as cool and not as complicated. Just something very simple, like, hey, knock the balls into this trigger zone to open the door, stack these cubes so that you can jump on them, whatever it may be. Something simple like that. But that should be really interesting to figure out, because once I get into that area, I'm really going to have to figure out how all of this works. Where do things live in the scene, as I was describing before? Do I instantiate them like runtime? How do I like prefab things maybe? How do I split things up in terms of like source files down here? It's pretty different thinking to how it is in Unity land. This is kind of a bit raw and lower level, so it's interesting. The course, by the way, everyone, link is in the description of this video. Highly recommend it. If you do, I do get a small percentage commission. It's a referral link. Just full disclosure there, but it's something that I recommend, and it's going great for me. So check it out. It's on Udemy. Anyway, that's it. I'm going to stop there. Have a great night all. Catch you in the next one.